everybody, welcome back to my channel. Today I'm thinking to build wireless energy transmission, and we'll see how to build its circuit, how it works, everything in detail. So let's get started. I was thinking what project should I build next, then by seeing Nikola Tesla I got an idea. Why not to build the wireless energy transmission? So that's why how I started this project. The best and easy way to transmit electricity wirelessly, what I thought is by using mutual induction. By the way, how transformer works. So this is a transformer without its core, and you can see there are two coils. They are coupled using something iron core like this. So what I thought is by separating the two coils from the same body and using it separately, I can make mutual induction and transmit electricity wirelessly, something like this. I have two coils, and this I'll send the electricity through this or the current through this, and this will be the receiver coil. So let's get started. So those who know about mutual induction can skip this part, and those who know about it can watch this part. When we connect a wire across a battery to positive and negative, the current flows through the wire, and as the current flows, there will be magnetic field produced perpendicular to the wire. By using the same concept, we make that wire into loops and call it as coil 1 and coil 2, and we give an AC signal to coil 1 which changes its polarity at every frequent interval of time. As the input signal changes its polarity, the magnetic field also changes. Similarly, when the coil 1 produces a magnetic field and coil 2 is in the surroundings or the vicinity of the coil 1, the coil 2 also produces an EMF due to Lenz's law and Faraday's law. And in transformer, to increase the efficiency, they use a core, iron core. But as you want to build wireless electricity transmission, they are going to avoid that. So this is the basic how it works. But what I'm going to do is, instead of using an AC source, I'm going to use a DC source. But as you know that if I use a DC source, the problem what happens is the magnetic field doesn't changes. But according to Faraday's law and Lenz's law, the magnetic field should change to induce an EMF in the coil 2. Therefore, I'll use a square wave such that magnetic field still changes, and I also get the output as a square wave, and I can use that as anywhere. So I have built a circuit like this. If you don't know how to connect using breadboard, you can see my previous video in which I have shown how to use a breadboard. So this is a battery and this is coil 1, and I'll tell you about this green wire later. And this is a LED, and this is the coil 2. I have connected nowhere else. So now when I power it with the battery, the LED doesn't turn on. So what I can do is, instead of giving it a continuous supply, I can turn the battery on and off very fastly. So now I have connected the switch and I have placed this coil on top of this, and the LED is here. So I can turn on and off the power supply fastly using this switch. So let's see what we will get. Oh, the LED barely blinks. I'll turn off the light. Okay, now you can see. So how fast the switch is turned on and off, on that the LED also glows like that. So it's better to turn on and off the switch very fastly, which I can't do. So let's upgrade this circuit and make a better one. Now what I'm going to use is this is a PWM signal generator, and I'm going to use this instead of a switch or a push button. So basically what it does, it creates a square wave, or it turns on and off the coil very fastly, and it can be controlled using this function, the frequency function and duty cycle. So don't think much about this, I'll explain this in another video. Now duty cycle I'll set it to 50%, and frequency I'll set it to 50 Hertz. So I have connected this to an LED to show what is a square wave and how it generates square wave and how I will use it to operate this coil. When I turn on, the frequency is 1 Hertz, and as you can see the LED blinks according to the frequency, and I can change it. If I make it 2 Hertz, it blinks faster. 3 Hertz, still more faster. Similarly, I'll make it to 50 Hertz as my frequency. Okay, this is the 20 Hertz. Okay. Okay, the LED is actually blinking, but it's blinking so fast that it's not visible to the naked eye, and it almost feels like that it's continuously on. Now I'm going to, so yeah, the magnetic field is produced in this coil. Now I'll bring this coil on top of this and let's see if the LED blinks. I have connected the LED nowhere else. I'm showing it again. Now as soon as I bring, yeah, the LED glows. I'll turn off the light for a better view. See, you can see the LED glows. As I bring closer, it glows more brightly, and you can see it's also blinking at 50 Hertz frequency. But rather than using a PWM signal generator, we can also do this circuit by using only a MOSFET or a transistor. But I'm going to use a MOSFET, as MOSFET is much more powerful and can handle more loads of current. So I'll remove this PWM signal generator and build the same circuit only with the MOSFET. So this circuit is called as self-oscillator circuit, and I'll explain how it works. So basically there are two coils, but when you see on the breadboard, you can see that there is only one coil, but it is a center tap coil. It appears to be one coil, but there are two coils connected in series, and this is the one common center of the both the coils. So basically this is a MOSFET I have used. As I said, I connected 10 k ohm resistor, and that this coil works as a feedback coil, and this is the main coil which turns on and off and creates the magnetic field such that it gets induced in the another coil, this coil. So what happens is, when there is a gate voltage in this MOSFET, it connects the drain and source. Actually I have shown here it as a switch, but there will be no switch inside a MOSFET. I have made it to understand easily. So when there's a gate voltage, the drain and source is connected and the coil 2 is energized like this. And when there is no gate voltage, the coil 2 is not energized. So basically what happens when I connect the cell or the battery, the current flows like this through the gate and it closes the drain and source. And as it closes the drain and source, the magnetic field in coil 2 began to increase, and as the magnetic field increases, there will be induced EMF in this coil as E equal to minus L di by dt. As there is EMF in this coil, the gate voltage also increases, and therefore the drain and source remains connected, but at one certain amount of time there will be no change in magnetic field in coil 2. As there is no change in magnetic field in coil 2, there is no more induced EMF in feedback coil. Therefore, there will be no gate voltage and drain and source disconnects. As drain and source disconnects, there will be change in magnetic field from very high magnetic field to no magnetic field. Therefore, the feedback coil also again EMF will be induced in that and turning on the gate coil and gate terminal of the MOSFET. As the gate terminal of the MOSFET is connected, again drain and source get connected and coil 2 again turns on. And this cycle keeps on repeating and makes the coil 2 turn on and off rapidly. And it turns on and off the coil very fastly so that it can produce an EMF in the in this coil. So that's how the self oscillator circuit works. And for the explanation why I have added the 10 k ohm resistor is that there are parasitic capacitance in the MOSFET which prevent the MOSFET turning on and off very fastly. To remove that, I have added a 10 kilo ohm resistor. So what happens? The we can give a capacitor the another part to flow through this resistor. So this is how we made wireless electricity transfer. Now let's build this on the PCB. Okay guys, so finally I made it on the PCB. As you can see, this is the negative terminal of the battery and positive terminal of the battery should be connected here, as so like this. And you can see it has come out very nicely. So just imagine using this thing here, it takes up so much space. So let's connect and test it if it works or not. So I'll connect battery positive here and negative here, and this is my coil where I have connected LED. So first I'll turn off the lights, I'll turn on the battery, I'll bring this thing here. Oh yeah, it works. Okay, this thing works like a charm. You can see there is nothing here. I have turned off all the lights and you can see it works so good. To test one thing, I'll turn on the coil here and I will put the other coil under the table here. So let's check if this turns on. Oh, just a second. I'll turn on the power supply. Oh yeah, the LED glows. Okay, crazy. Wow, very nice. So actually mobile chargers, wireless mobile charger also works in the same way. Actually the battery has discharged a lot, so it's not glowing as bright first how it was glowing on the breadboard. The another problem is the MOSFET gets hot, so it's better to add a heatsink. I couldn't add a heatsink because I don't have thermal paste, so I'll get a thermal paste and add a heatsink to the MOSFET. So tell in the comments how did you like this project, and also show it for your friends. Really cool project. Meet you in another video.